In this question, we are trying to find the net external force on an object that is sitting at an incline. And we're also trying to find what the angle of that incline is. So the question is, a box slides down a ramp at an angle. The box has a mass of 9 kilograms. So the first part says, calculate the force of gravity on the box. Well, the way we do that is we got to remember that we take our mass in kilograms and multiply that by acceleration due to gravity. So 9 kilograms times 9.81 meters per second squared. Put that in your calculator, and you end up getting a force of 88.29 newtons. And we're not going to concern ourselves with sig figs now. We're just trying to get the concept down. So 88.29 newtons, that is the force of gravity on the box. The next part says, if the normal force is the force pushing off of the ramp, if the normal force of the ramp on the box is 75 newtons, what is the angle of the ramp? Well, what we can do here is we can draw a force diagram. So here's gravity, force due to gravity, and here's our normal force pushing off like that, normal force right here. And friction would be pushing up in this direction here. That's force due to friction. And so we know that our force due to gravity is 88.29 newtons. We just calculated that. And our normal force is 75 newtons. So basically what we have to remember is that this right here is a 90-degree angle. And if we want to figure out the length of this side, or the length of this side, or the length of this side, or the angle at which it's at, we have to use trigonometry. And the way we do that is by recognizing that this 90-degree angle allows us to rotate the orientation, rotate our how we're looking at the directions of these forces, so that we can put the force of friction on the x-axis, the normal force on the y-axis, and then gravity is kind of going down at an angle like this. There's force due to gravity. And so now we can draw a little triangle here, and what we recognize is that because the object is not accelerating away from the ramp and it's not sinking into the ramp, therefore this side of the triangle equals this side of the normal force. And therefore, if our normal force is 75 newtons, then the length of this side of the triangle is 75. And the length of this side of the triangle would be 88.29, which is what we had as our force due to gravity. Now we have two sides of a triangle, which allows us to use trigonometry in order to find out what the angle is. So if we label the different sides of our triangle, this right here is the hypotenuse. This over here, this is the adjacent side. This is the opposite side. And so what we can do is say, all right, we have the hypotenuse, we have the adjacent side, and we're trying to find the angle. So therefore, we're going to use the inverse cosine function. Inverse cosine of the adjacent side over the hypotenuse, and that gives you your angle. So you put that into your calculator. So the inverse cosine of the adjacent side is 75 newtons. 75 newtons divided by 88.29 newtons. You put all that in and you end up getting an angle. Make sure your calculator is on degrees and not radians. 31.85 degrees. That is the angle of the ramp. Okay. So next part says, what force would be needed against the direction of motion to prevent the box from sliding down the ramp? So if the box is sliding down the ramp, friction is going to be pushing against the direction of motion, against the object sliding down. So in our drawing right here, in our force diagram right here, we see that this side of the triangle right here, this side is counteracting the force of friction. So what this question is really asking is how do we find, what is this side of the triangle? Well, in this case, we have two sides of the triangle already, and that means that we can use the Pythagorean theorem in order to solve for the third side. So in order to find what that third side is, which is, I guess, if this is A, B, C, this would be A would equal would equal c squared minus b squared, and in that case c squared is our hypotenuse squared, which is 88.29 squared, minus 75 squared. You put all that into your calculator, and what you get is 46.58 newtons. Again, we're not paying attention to sig figs, we're just trying to get the concept right. So 46.58 newtons, pulling the box down the ramp. So the next question asks, if the force due to friction is 36.6 newtons, what is the net external force on the box? And so basically what we're trying to figure out is, can friction stop this box from sliding down the ramp? Well, if the force of gravity in the direction of motion, pulling the box down the ramp, is 46.58 newtons, well, what we can do is I say, all right, that subtract 36.6 newtons, and what we get is a net force in the direction down the ramp of 10.0 newtons. And that, because that is non-zero, therefore the object will be accelerating down the ramp so 10.0 newtons is the force pushing it down. And I just answered our final question, will the box remain at rest with no net force, or will the box accelerate downward? And there is a net force. And we just concluded, because there is a net force, it will accelerate downward.